Hello, hello. Welcome to this stream. We are doing a live code Tuesdays. This is the first in a series of a live code stream where we will be streaming live. My name is Sohan Maheshwar. I'm a dev advocate at Fermyon, and I have Radu. Radu, welcome to the show.
Hello, everyone.
Yeah. Radu is a CTO at Fermyon, and the point of the stream essentially is we're going to try and build like a live app with y'all. So nice. So yeah, let us know, where you're joining us from, what you want to see us build. Radu is going to show us a very cool example of building an serverless AI inferencing app using Spin, using WebAssembly, using serverless. If all of that is intriguing or you're curious about, well then stick around. Radu, you're in a position, I think, to tell us better what we're going to build, right? So let's go jump straight in.
Yeah, rather than, we're mainly going to try to build an application, and you're going to see me mistype words and try to use my relatively new keyboard.
Ooh, is that a
So
mechanical keyboard, Radu?
it is a mechanical keyboard. It's a split mechanical keyboard that
Nice.
I've in the process of getting up to speed with my typing speed. So we're gonna build a very simple chat application at least this week, and we'll try to build on top of it. There is a very simple example of the starting point for this application is something like this: a very simple chat UI with a message history and then a text area with a couple of buttons. So the goal is to get the application and get the send inferencing to a large language model, and in the process use things like key value storage and configuration, and build a serverless spin application that has multiple components, deploy that to Fermyon cloud, and get a sense of how do we actually build something like this from mostly scratch. I'm going to spare everyone the process of me building this UI from scratch. I'm gonna cheat and use the HTML and CSS that I built already for this. So it's really no one's best use of time to see me try to write CSS or HTML. So I'm just gonna lift this from a gist that I created earlier today, and we'll use this as a starting point. So we're literally going to start from a spin view. So are we ready to get started?
Yeah, for sure. And completely agree with you, Radu. Writing CSS is not for the faint of heart. Again, this is a sort of very informal format. So if you have any questions, for those of you all watching in, please put them in chat. If you want to say hi to us, let us know where you're watching this from, and we'd be super happy as well. Radu, why don't you go ahead and let's start building.
Yeah. So the starting point for all of this is Spin, which I already have configured on my machine. If you don't have it on your machine, then you can go to developer.fermyon.com and go to the Spin documentation, and the quick start will guide you through installing Spin. I have instructions for macOS, which is my operating system, and I just did this. I have Spin 1.5.1, which is the latest release of the Spin project, and I configured the if you look at the install script, it will see it will configure templates and everything else we're going to use. So we're going to build a Spin application with basically this structure. So it'll have two primary components. It'll have the web UI that will contain the chat interface, which is just a static web application, just a bunch of HTML and CSS and JavaScript. And then that front-end application will call into a serverless backend that we will deploy to Fermyon Cloud. And then that backend will have three primary endpoints that we will have a look later to see whether we'll build it as a single component or multiple components. But three primary goals: generating next item in a conversation using Llama 2, and then two components related to history, getting the history, and then deleting the history related to a specific conversation. So if you've ever used something like ChatGPT or Bing Chat or any of those things, it's a very, very simple example of using the inferencing engine that we have in Fermyon Cloud and then building something that is basically a full stack serverless application that uses, on top of inferencing, things like key value storage and building web applications and talking to databases and caches and things like that. So this is the functionality that we're going to build. And
Nice.
yeah,
Right. I'm quickly going to just say hi to Raymond. Raymond's saying joining from Toronto, Canada. Well, thank you so much for joining in, Raymond. If you've done work or if you've built something cool in the WebAssembly spin space, let us know in the comments. Or yeah, just let us know what you're working on. We'd love to hear from you. In case you joined the stream late, Radu is building a serverless AI app, and we just started. So literally, first step. So you didn't miss that much.
Yep.
Radu, go ahead.
Hello, Raymond. Okay, so ideally you'll have had the time to get spin and then go through the quick start guide. You have the getting started in the repo README as well. And at this point, we're just going to do a spin U and just let it walk us through the process of creating an application. So it's telling us we were starting from scratch. There's literally nothing that I have up until this point. So what I'm going to do is I have a very particular application structure in mind. So this is the application that I'm trying to build. So I'm just going to start with an empty application. So it will just create the spin.toml file for me. So I just want my new stream app. And then I'm not going to give it a description. And it created my new stream app. So this created, well, two files. If we look at it, it created a gitignore file, which ignores the .spin directory and any WebAssembly files that we might accidentally commit to source control, and then a spin.toml file. And the spin.toml file is basically the application manifest for Spin. So I'm just going to delete this because we're not going to use it. And it has Spin manifest version, some metadata, and then this tells us that it's an HTTP application. So we're building a serverless API. And then this is the version of application. I'm just going to do 0.0.1 just to indicate that it's really, really underbaked and not ready for anything. So at this point, my new stream app, our application has no components, right? There's nothing here that tells Spin to run anything. There's no WebAssembly module. There's nothing, right? So at its core, Spin is a developer tool for building serverless WebAssembly applications. And at the core of a Spin application is a component. So what we've seen up until this point was we've used Spin U, which is the CLI that helps us scaffold either applications or components. So we did Spin U to create a new application, but now we're going to use the Spin add CLI, which basically lets us add new components into existing applications. So this gives you the ability to create any sort of application structure you might have. So in our scenario, we're going to do Spin add twice, or at least twice, depending on how we want to structure the backend. But first of all, we're going to do a Spin add, and we'll try to create the application component for our web UI, for our chat. So we're going to do a Spin add, and then we'll let it guide us through the same process of picking up the template for our component. And our component is, as I mentioned, a simple UI, a static UI. So it's going to use the static file server template. So if you're building any sort of website with Spin, any sort of web application that has a static application component, you can just use the static file server component and template that we've built. We'll just call it web. We're going to let it handle every single request. So when we go to our application.com, it will invoke the static file server, and then we'll just create a directory called web. So this added our component to spin.toml. This tells Spin that the source of this WebAssembly module is our GitHub release for the Spin file server project. And it has a digest to verify that that's the actual component. And then it tells it that any file in the web directory that we will create in a second will be mapped, and files there will be served in our static file server. So for that, we'll need to do make directory for web. And this is where I'm going to cheat a little bit and just use the starting point that I mentioned. There's really no use for me to write HTML. So we're going to be, I'm going to create those files. And so it's index.html that has this HTML, and then a very bare bones. By the way, I'm not going to use any sort of front-end framework for now. We might leave that as an exercise for next stream. Main.js, I'm using plain JavaScript and literally get element by ID. So if you have strong opinions about the specific JavaScript framework that I should use, we should definitely chat about it and have a.
I think JavaScript and strong opinions are go hand in hand. JavaScript frameworks and strong opinions. Folks, for just joining in, this is Live Code Tuesdays. My name is Sohan. I'm here with Radu, and we are building a serverless AI application using Spin. Again, all of this code is on github.com/RaduMate. And we'll be doing this over a series of live streams, so you can always catch up. Yeah, let us know where you're watching this from, or if you've built something in the Spin or WebAssembly space before. Radu, I had a question. So in that spin.toml file, there was something called a trigger, right? Is that something that's mandatory for every Spin app that I'm building?
Yes. So a Spin application is basically a collection of components, all of which are triggered by a specific event. So in our scenario, in case of this application, the event is going to be an HTTP request. So this is defined for Spin 1.x, or 1.5.1 is defined as one trigger per application. And then every component defined in that application manifest has a trigger configuration section that basically defines, in case of HTTP, what is the path, what is the route that this particular component will handle, so that when you're calling into your application endpoint, so this will, when I'm going to run this locally on localhost, it will be localhost 3000, and then I'm going to have a path. Component 1, component 2, this component trigger configuration defines which component is supposed to handle which path. So, and you can have components that have different types of triggers. There's a Redis trigger that you can trigger Spin applications to be executed whenever you have messages on a Redis trigger, or you can have things like custom triggers like SQS for AWS, or Kafka, or any of the open source triggers built by the community for Spin. So Spin is entirely extensible and pluggable here. If you're interested in other event sources for Spin applications, please comment and reach out to us. There are a bunch of them that you can find on our GitHub and in the SpinUp hub. Mm-hmm. So at this point, the structure for what we have in our application directory is there's the spin.toml file that we just saw. And then we have the web directory with an index, HTML, JavaScript, and CSS file. And as I mentioned, that's all the web front-end development that will take place in this stream. And at this point, I think we can do a spin up. And ideally, whenever we're going to localhost 3000, we should ideally see a web UI. So yeah, mm-hmm. that's the web UI that we've just built, and nothing's going to happen, right? So let's have a look at
quick question
first
again,
of all,
what is spin up actually doing?
Yeah, spin up will just run the application. So
but locally,
spin up, we'll run it locally, right? So if you look at this, doing spin up, and then it says serving 127.0.0.1, which is localhost 3000. At spin up, spin will, depending on what type of application you're looking at, if it's an HTTP application, it will start a web server locally that's ready to listen for events. And then whenever there's an event that matches the route or the path that you're trying to handle, it will basically instantiate the WebAssembly module that you're defined as the source for your component, the WebAssembly component, and then execute that function. If you want to have a look at what the spin file server component does, that is on GitHub. Spin file server. And basically, it's a Rust application that just serves static files. So if you go to the source of that, it does handles a bunch of things like compression and fallback paths for 404 pages and a bunch of other things. But the main thing here is this function that takes in a request, returns a response, and basically tries to map the request to a file in the file structure that you've defined here. So in this scenario, this maps all the files in the web directory to the root of the component, so that, and then the route for our component trigger, it handles everything. So whenever there's a request for 127.0.0.1 index.html, this file gets served, right? And then the index.html file requires main.js and style CSS, which basically leads to the execution of 3 WebAssembly instantiations whenever we send a request. So whenever we refresh this, for every single time we refresh this, the web browser requires the HTML file and then requires the CSS and JavaScript file. And every time that happens, this WebAssembly component gets executed. And that happens across the board. It doesn't matter that if it's a static file server component written in Rust or an API that we're going to write in TypeScript or whatever. This will basically happen every single time. Cool. So at this point, yeah, as I mentioned, we have our spin application that runs locally. Now that it runs locally, we could technically do a spin cloud deploy and have it deployed to Fermyon Cloud. So instead of running it locally, this will upload the application to Fermyon Cloud and execute it and have it available on a subdomain on the Fermyon.app domain with a certificate and highly available in our infrastructure. So we've gone through spin new, spin up, and now deployed, and now our application is available on my new stream app, something.fermyon.app. So this is now live on the internet. If it does nothing, literally nothing. If you say anything, it will error out because there's nothing there. But we have deployed our application, which is now live and highly available with an HTTPS certificate. And then we can go to cloud.fermyon.com, and it's called My New Stream App.
You have a lot of apps.
I have a lot of apps, yeah. My New Stream App, it's here. It got precisely, a couple of requests and no logs because there's nothing happening yet. So cool.
Awesome. Very quickly, folks, for those of you all just joining in, this is Live Code Tuesdays. We're building an AI app with Spin. I'm Sohan, and we have Radu here. We're just going through the steps on how you can build a serverless AI inferencing app. Raymond, thanks for your comment. Raymond says, I'm considering using Spin to add functionality to a healthcare SaaS platform we're building, with AI being part of it. That's super cool, Raymond. Happy to even have a chat after the stream, and bounce ideas if you want. Very cool that you're actually building something like this with AI being a part of it. Yeah, and stick around for the stream.
Yeah, really interested in chatting about exactly how that works and what your experience is using Spin for this. Cool. We've managed to build one application with one component that is a static file server and nothing else. So let's add some functionality to this. So back to spin add. We're basically at the point where we want to add new components to our application. So we're going to use spin add. And we use the static file server because our initial component was a static website. Now we are going to need some API functionality. So we're going to choose a new language to write our application. I'm still on the fence between using Rust or TypeScript. I think I'm going to go with TypeScript for this one just because it's JavaScript and TypeScript are quite popular and it's really easy to get started with something. Rust is still by far my favorite language, and I'm eventually gonna find a way to sneak Rust into this stream eventually, but not right now. So I'm just gonna name my component API. I'm not gonna give it a description. This walks me through basically generating the configuration that we're seeing here. So it tells me what's the name of the component, what's the route for the component. All of this is configurable when building templates. And at this point, I now have a new component. So not only do I have a new component, but I should also have a new directory in my application called API. And spin add also scaffolded the configuration not only for which route this application is supposed to handle, which I defined as API, but also how do I build this component, right? So we're now going to just going to quickly cd into that and do npm install. If you're using like pnpm or bun or anything else, it's just a package JSON file, so you should be able to use whatever your favorite tool is to build to install dependencies. So now that I did that, Spin has another command called spin build, which just iterates through all the components you have in your application manifest and runs their component build command. So you can define a build command with a directory, and whenever you run spin build, it will just go through each of those and execute that command. In this scenario, that command is literally just npm run build. Spin knows nothing about how you build your application. It just calls into your toolchain, which in this scenario, it's npm run build, and we can obviously inspect that. npm run build does, well, a bunch of things with Webpack, and then a spin just WASM plugin that we can talk about it in a future stream.
For folks just joining in, we are live coding AI app with Spin. We're going through all of the steps on how you can actually build a simple chat app, something like ChatGPT, using the Llama 2 chat model. Right? And we're doing this using an open source framework called Spin. This is a very informal sort of thing, so let us know where you're viewing this from. If you have any questions, please feel to put it in the chat. If you want us to build something specific, and if you want to tell Radu that, hey, TypeScript sucks, I would much rather have you build it in Rust, well, that is also fair game. Radu might actually prefer that, but hey, we're going with TypeScript for now.
Yeah, I'm looking for any excuse to show Rust in public.
Yeah.
Anyway, so at this point, the build step is the thing that, if you look at the application manifest, Spin adds scaffolded in a component source that whenever there's a request matching this component, Spin should instantiate the component found in API target api.wasm. And it's the expectation that the build command will actually build that component. So if you look into the API target directory, there's an api.wasm component that we just built. And this is a 2.4 megabyte component. So this is the entire API, the entire backend for our application. If you're interested in how large the static file server is, you can look into the release page, and that's like 3.8 megabytes. So the entire application will be really, really small, and it's supposed to start really fast.
And
so
that's one of the advantages of like a WebAssembly and using Spin as well, right, Radu? Like your binary size and your application size is reduced.
whenever you have to deploy the application, you're literally just transferring 2 megabytes from the JavaScript endpoint, from a JavaScript API, and 4 megabytes from a static file server, and a bunch of metadata and anything else you might have as static assets. And in this scenario, it will most likely be like less than 6-7 megabytes, which means it will be deployed really, really fast, and also it will instantiate really, really fast. The whole point when building something like this is, when building a serverless framework, you want it to be really good at high density. So you want to shut things down and then start them up whenever there are requests. So starting up something that is 4 megabytes or 2 megabytes is significantly faster than starting a container image that might be like 100 megabytes or 50 megabytes or whatever. So at this point, this is what we have. We have spin.toml, we have web, the web static website directory that has my very fancy front-end application, and then the JavaScript API that we had a brief look at our build script. Just going a little bit further on this, there's literally just one dependency, the Spin SDK, and then we have a bunch of dev dependencies for loader, TypeScript, and Webpack to package everything up. And let's have a look at our application, our endpoint. This is the default JavaScript or / TypeScript component. It has exactly one function that we can simplify a little bit. We'll have a look at it in a second. There is a lot of type information here in type safety, so that in case you mess anything up, static type checking will tell you that something's not working properly. Yeah, let's tweak this a little bit. I think we can update the templates a little bit. This is not necessarily needed. You can just pass a string as the body. So hello from the live stream. So now when we do a spin build and a spin up, whenever we call the API component, curl localhost 3000/API, we should see hello from the live stream, which means Spin successfully instantiated this component and then executed this function whenever a request that matches this came in. So we now have the setup for the web of the API backend and then the static website. We now have to put them together to talk to one another. So let's look at that. In the meantime, we'll look at one other thing, which is spin watch, which is a tiny command that lets you. So I did a change, I did spin build, and then I did spin up. And I would have to stop spin up, do a change again, do the whole dance. Spin watch just does that for me. And it will just watch my application and rebuild and restart the app whenever there's a change. So at this point, I should be able to spin watch works, save it. And of course, I didn't define any configuration for watch, so it doesn't know how to do that. And this is our chance to look at the documentation for it. So developer.fermyon.com, spin watch help. So spin watch tells us that, okay. Watch. There's a spin documentation that tells us.
I think you mentioned the src/.
Yep, I need to point to
the TS file, right? Yeah.
Yep. So I think.
In the meanwhile, Raymond, actually, Radu, looks like you have a friend, because Raymond also is using Rust for backend services on his platform. So there you go. Good job, Raymond. We're all fans of Rust. I mean, no hate for like JavaScript and TypeScript, but our SDK is also built on Rust. So there you go. Yeah.
let's see if that's the right config for SpinWatch. So I should be able to SpinWatch actually works. Yep, so it detected that a file was changed. It recompiled the application and then restarted it. So we should now be able to like save the application and get it to automatically update things. And let's see if watching the file system for our web app also works. So chat with Spin and Llama 2 from the live stream. Yep, I think so. Yep. Okay, so we should now have the setup for everything. Okay. Let's now have a look at that web application and what's happening there. So really straightforward. We have a chat container, which is this whole thing, this div. And then we have a chat history div, which is this area here where conversations will appear. And we'll have a look in a second where that's coming from. And then we have a chat input, which is this text area here, and then two buttons, one to send, one to clear the history. And the JavaScript that's attached with this is pretty straightforward. The send message button, whenever that's pressed, will take the message input value and then send it to the API. And then send it to the API, just sends it to /API/generate. So we defined our application to have an API endpoint. And that API endpoint is our JavaScript API. So this component will handle any request coming through the /API path, and it will execute this function. So at this point, hi from our chat application. So we save that, it's rebuilt and restarted. And now when we send any sort of message, it will say, hi from our chat application. Does this work? Hey, what is happening? Well, every single time we send the request, the component model, the component is instantiated, and this function gets executed. And this function literally always sends hi from our chat application. There's nothing there other than hi from our chat application. So wherever we send here, it will just be the same message. But what we've built so far is we managed to correctly send a request from a front end to a back end and have our application actually connect the front end and the API. So at this point, I'm feeling pretty happy with how our application looks like. So I'm just going to do a spin cloud deploy to make sure my application's live with all the changes. There's also a GitHub action that you can configure to build and then push the application to Fermyon Cloud whenever CI runs. So you don't have to do this from your machine. But now Spin Cloud Deploy will tell me what happened. I now have two available endpoints in my application. One is the web application, and the other is the API that we just defined. So now when we go to the application, which is like my new stream app.fermyon.app, which is the endpoint that we got initially when deploying the app, it should say hi from our chat application. And the one thing that I want to point out here is before deploying this application to Fermyon Cloud, none of the WebAssembly assets, none of the WebAssembly components existed in our infrastructure, in Fermyon Cloud infrastructure. So every time I now send any sort of message, literally Fermyon, our infrastructure in Fermyon Cloud is loading the WebAssembly component and instantiating it and then shutting it down. So you're basically invoking WebAssembly modules and WebAssembly components every single time we're sending a request here. So that's we now have something that's actually running in Fermyon Cloud that has two components. And I think we're finally ready to add some real functionality to this application. So
Yes, let's do it.
Okay.
Yeah, again, sorry, folks who are just joining in. Yeah, we are building an AI app with Spin. And if you have any questions, or if you just want to say hi in the chat or where you're viewing from, let us know in the comments. Radu's built the front end. He's built the back end, which is just sort of sending a static message. And now we're actually going to add like some sort of intelligence to reply to those messages. And we will be using a large language model, an LLM, which everyone's talking about. So yeah, Radu, take it away.
Thanks. Okay. So this is the point where I am going to the documentation, just because I don't remember all the things. So JavaScript, building components in JavaScript. Okay. There you go. Okay. So what I want is to be able to route requests on our API so that I don't have to manually check things like what is the path for this request and something like that. So I'm basically just using the router built into the JavaScript SDK, which is in turn built on ED router, which is a really popular JavaScript router, and basically defining a router and then be able to do things like router get or router post and have things like parameters. So let's do that. So if I let and I get IntelliSense and code completion from this, I need to import the router. And now what I need to do is router dot, and now I get completion for what the available things on the router are. So the idea there is our serverless backend will have a couple of components. We'll just start with the post component that asks the backend to respond to our request, respond to a generation completion request. And this is a post request that will contain some conversation prompt. We'll look in a second at how that would look like, but the idea is we need to have a post endpoint that has a request body that we have to read. So let's do router.post, and then we need to define the path that our application is going to listen on. The component is already listening on API, so we're going to have it listen on /API/generate, and then we have a router handler. So if you go back to the documentation, this tells us that this router handle is a function that takes some parameters, and we'll look in a second at what that would look like. And I'm just going to do it all in async. This is just a lambda function in JavaScript. Lambda is in the anonymous function model. And this will, let's just have it return that response. And then whenever we call the actual entry point for a handler, we'll have it return router dot handle request. Yeah, handle request request.
Oh, is there a typo there?
Yeah. Yep. Okay. So this should give us the infrastructure to now handle And now we have router.all, and we can define a catch-all endpoint async. I'm one of those people that add semicolons in JavaScript/TypeScript. So if you don't appreciate that, you might get annoyed.
You're saying a lot of controversial things today, Radu. I thought
I
we were
know.
going to do a very
I
non-controversial
know.
stream today, but
Okay, and then for everything else, we're just going to return 404. We don't need any headers. And then, yeah, we don't need anything there. So,
Radu, if you can just summarize the code that you wrote here with the routing in like a couple of lines.
Yep. Okay. Yeah. So the entry point in the spin template is very simple and just basically handles every single request coming to the components. And Spin SDKs, in particular, Go and TypeScript, JavaScript, and Rust have a router utility that helps you handle specific methods and specific paths in a way that is just, if you want to build functionality in the same component, you can just use the router to just handle different paths and different methods in your application, and it's just a utility. You could have done the same thing in this function. Router just makes it easy to structure your code in a way that makes you happy, and this is what. Yeah. Okay. Okay. So at this point, go back to running spin watch. Nothing should have changed other than the new 404 endpoint. So when we actually call API generate, our application will respond with hi from our chat application. Other than that, it should return a 404. So curl API -v. Yep, 404 not found, and then API generate also not found. But this time it's a not found because this is a HTTP post method. So we can do -x post, and we should see hi from our chat application. Nice. So this works. Now let's see if our application still does anything. Yeah, because our front end does indeed send a post request to our application. So let's dive into what this actually does. So I mentioned that whenever we press this button, the send button, this function gets executed, send message to API, and this one just does fetch to API/generate and sends a post request with a JSON body that contains an ID and then the actual message content. So let's print this. So let's do console.log. Okay, how do we get the body here? We have no functions here. We have no parameters here, but we do have the request object here. I think there's a way to simplify this. Request.body. And now we have both the request and console log. Okay. The request body might not be a string, might be an array buffer, which is what it is in a JavaScript. So we need to decode that from an array buffer to most likely a JSON object, because that's what we are sending here. So we need a text decoder equals new text decoder. And then we need to let body equals decoder.decode of the extra parameters that we are passing along to this function, and then body. Okay. So at this point, we should be able to log the body, and let's see if that works. So the body should now have a random, there you go. Now we have an actual error,
Yay.
which says cannot
First
read
error of the
property
stream,
buffer.
Radu. Yes.
Yep. Cannot read
I'm
property
excited.
buffer of undefined, which means that we are not passing the request body properly. Okay, let's see where the error is. Okay, let's go back to the documentation. Okay, so this says,
and folks just joining in, I see a few people have just joined in the stream. Yeah, this is Live Code Tuesdays. We're building an AI app with Spin, warts and all. So yeah, you're seeing us build an app live, right? And yeah, we're looking in the documentation. We're building stuff. If you have any questions, if you want to say hi, if you want to tell us where you're watching this from, put it in the chat. We'd love to hear from you. And yeah.
Yeah, this is the router object lets you pass extras, as in you can bundle anything you want there, and you're just bundling the request body. And so now we should be able to see the logs from our application. So, hi. Okay, no more error. But we're also not seeing the logs. This is interesting. I would expect that I should be able to see the logs. Oh, it is printing. It's just empty.
Okay.
Yeah, okay. I can do this body. Yeah. So yeah, it's printing is just empty. Okay, cool.
Yeah.
So we're not actually passing the body properly. So let's see how we can do that. Okay. This is the body. Sorry, this is the button, which is get element by ID for send button, and this is the function that ends up sending this.
Oh, Karthik says you may be looking at body.body.
Oh, let's see. Body.body. Yeah. Nope, I don't think so. Yeah, I don't think that's the. I think we're just not. We can do this actually. HD hello. Yeah, we're printing properly. It's just we're not yet sending anything from our front end from the body. Yeah. So we are printing properly. So let's see how to send this properly. So on a click event, we want to trim if there's any new lines or space at the end, and then add message to chat history. We want to like differentiate in colors between users and assistant, and then send message to API. So let's see. console.log conversation ID console.log message. And okay, this is how you know this is actually live coding.
What's the message there? The text is too small for us to. Oh, JSON? Okay.
Yes, because it's trying to fetch some history that it's not there yet. But it's not. Okay, let me. Hi.
So the message is empty, basically, right?
Yes. Yep. And when in fact it should be able to. Oh, this is not actually getting executed. So this is not calling the right method. Okay, the router is not calling the right router. So, okay, let's do this. Console.log received request, which is like your first debugging.
Yes, console.log is my friend.
Okay, so we should see here received request. Okay, cool. And now we should also see it from our application. Hi. And we're not. Okay, cool. So at least we know where the problem is.
Yeah.
So I think I might know where the problem is coming from. So this is calling localhost 3000 API generate. Let's look at the network tab here to see what this is, what's calling what. Hi. Okay. This is calling. Oh. This is the dumbest possible reason why the app is not working.
Is that a
I am
Flash?
No, I'm debugging the app that's running in Fermyon Cloud, and I'm changing the app that's running locally. So let's just hide that.
Yeah.
Yeah. Okay. Okay. So now we are actually receiving we're receiving the request body properly, and we should be able to start deserializing it. We're receiving an ID, which the front end generates, and then the actual content of the message. Cool. Okay, let's create a very simple interface for that. For something like a user prompt. Interface user prompt. We basically want to deserialize the JSON into this. So we have an ID, and then we have content. Okay. So whenever we receive this, let body equals, we basically need to use the JSON parse. JSON.parse this, and I'm just going to be lazy and do as user prompt. And now this is a user prompt. So this should now be printed pretty. Okay, let's see. Hi. Okay, we have ID and content. We have the right deserialization of our body. And the goal right now is to basically send this message to a language model and get it to like run inferencing on whatever a user writes, and we'll deal with the whole like history and everything else in a bit. So what we want to do now is take the input and then just send it to the large language model. So let's have a look at the documentation for this.
Yeah, I'm going to give a quick recap, Radu.
Yep.
Yeah, folks, for those of you all just joining in, we're doing Live Code Tuesdays. We're live streaming how we're building an AI app with Spin. Right, so if you just joined us, my name is Sohan, we have Radu. What we have done so far is we've used Spin, which is an open source framework for building serverless WebAssembly. We created a Spin app, we hosted it locally, we've deployed it in the cloud. We added a front end to build like a chat interface. And now we're starting to build the AI aspect into it, right? So we built like internal routing within the app. So if you go to something.com/API/generate, it will hit this particular code. Yes, Radu, over to you. And yeah, folks, feel free to ask questions, send in comments, whatever. We'd love to hear from you.
Yeah, at this point, I'm going through the documentation on the developer.fermyon.com website and just going through what do I need in order to give my component permission to call into an AI model. So all I've done up until this point is I added AI models to my component, and now I need to I'm going to use TypeScript and basically just use this one, the LLM dot, I assume, yep. So we have LLM.infer. Okay, let's try this. Okay, so we're going to take the body. We're not going to print it anymore, and we'll do LLM.infer, and now it's asking us for a model. And if I remember correctly from here, you get inferencing models as an enum, inferencing models dot, we want to call llama to chat. We want to do body dot content, and then yeah, let's try to limit this to what, 10 tokens or something. Max tokens.
And what's a
10.
token here, Radu?
A token is in language model. It's a numerical representation of whatever the language model outputs, and it's a way to represent text or portions of words as a class in the vocabulary, and that's we're limiting the number of tokens that our application can return. And so this one should be able to let response equals this inference result, and then we can use this as, okay, let's log it for now. Console.log response. Now, running a large language model, in particular Llama 2 chat, which comes in like 7 billion, 13 billion or larger, 13 billion parameters, is something that you need a lot of resources for. And between sharing my screen and compiling code and doing all sorts of things, most likely not going to run pretty well. So I'm going to use a new plugin, Fermyon Spin Cloud GPU, maybe. Yep, it's a plugin that lets me just send inferencing requests from my application running locally into Fermyon Cloud. If you have a machine that's powerful enough for you to run on your machine, please do that. But I'm just basically going to do Spin Cloud GPU, and this has an init command that lets you just do that. I've if you're interested in running this and a local developer experience for this, please have a look at Spin Cloud GPU. It deploys an application in your Fermyon Cloud account that just proxies all the inferencing requests, which is pretty convenient. I did this already. It generated a runtime config file for me that I'm just going to copy here. It contains the endpoint for my application and a bunch of other things like a token. And now, instead of just spin watch, I'm just going to point to that runtime config file that contains the token for my application. So I think Karthik is around if you have any questions for this. It's basically my application will send requests to Fermyon Cloud regardless of whether it's running locally or in Fermyon Cloud. And then I have this runtime config file that tells Spin where my application is and where the endpoint and the token for that are. So basically, I'm hoping that at this point, whenever I make a request to LLM Infer, this will run in Fermyon Cloud instead. So let's see what happens here. So I'm expecting that when I'm going to send a request to my application, hi, what's your name? Ooh, yes, we actually get a request from the language model, which, okay, the name is Sherry. Okay. Yeah, let's ask something that, what is a bird? A bird, okay, a bird is a warm-blooded. It might have continued, but the maximum number of tokens we set is 10. So let's do 50 instead. Save that, get Spin to rebuild everything, and send another request. What is a bird? And now the request is sent to Fermyon Cloud, executed on a GPU instance somewhere, and returned back, which a bird is a warm-blooded, egg-laying, feathered, vertebrate animal. Okay, so I think we've gotten to the point where we are able to take a message from a user and have the message, send it to the language model, run the inferencing, and get the response back, as well as a bunch of other usage information that we get from our application. So let's finish this by actually sending the response back. So instead of the body being the same every time, let's just do response.text. And now, whenever this finishes compiling and restarting, what is a bird? It now should, maybe, yes, type our actual response. Okay. Most birds lay eggs, and I assume it would have continued. Let's now, my name is Radu, and we'll now see, it just continued randomly. Yes. Okay. But now the primary problem is whenever I refresh, it created a new conversation. It entirely lost all the context from everywhere. It's not able to do anything. It's not able to keep history, not able to retrieve anything, any new messages, and that's kind of annoying. But let's spin deploy this so that our deployed application can have access to all of this, and then see what we want to do next.
And yeah, folks joining in, yeah, feel free to ask questions in the chat. We are deploying our app in the cloud.
There we go.
There we go.
What is a bird? And it's now working, with the main caveat that there's no history, there's nothing happening other than every time we send a request, we deserialize the request body, send the text, the content to the language model for inferencing, and then return response and nothing else. In about, what, 23 lines of code. We built an API backend that just what is a mammal is able to execute requests. To Fermyon Cloud. So if we look at the cloud.fermyon.com, if we find the right application, my new stream app created about an hour ago, we now have the new logs from our application, and we can see the requests as they happened in the a timeline there, and then the logs from our app. Next time, whenever we're gonna continue this, I think it's worth exploring how to add history to this and do persistence for it. Basically use the key value store in Spin and Fermyon Cloud to do that. So there existing documentation on how to use the key value store for everything, and we'll use it to basically keep state across a single conversation, but also across refreshes, and maybe explore some more. But I think for 40-ish minutes of live coding, half of it was spent debugging things. What are birds real? Okay, let's see. Are birds
Oh, are we going down that
real?
rabbit hole, Radu?
Yeah, yeah, it's basically, this is literally just sending the text to a Llama 2 chat model, and there's no prompting, there's no guardrailing, there's nothing happening other than the raw Llama 2 model running in Fermyon Cloud and getting the response from there. So we want to most likely do a little bit of guardrailing and set a system prompt and tell it that it's an assistant and to be truthful, and a bunch of other guardrails there.
It's not always the answer though here. Tell us, Llama 2, are birds real? As an adult, what? Tell us.
So I'm gonna push this application to GitHub as the work in progress, and then we can pick it up next time.
Yeah, next week. Yeah, folks, quick announcement. So next week at roughly around the same time, we're continuing the stream. We will also have Josh from Civo. So Josh is the Chief Innovation Officer at Civo. We will be building this app, but he will also tell us about GPUs and all of the nerdy stuff around GPUs as well. Right, so join us then. This is the link. If you're watching it on YouTube, you can copy it, but you'll also find it on our YouTube profile. Raymond, big thanks for staying with us for the entire stream. Would love to connect with you to also learn about how you're using Spin. So, maybe we can connect on Discord or LinkedIn. For folks, we do have a Discord as well, fermyon.com/blog/Fermyon Discord. So feel free to jump in, ask us questions. If you need any help with your AI app, we are here to help you out. And also check us out on GitHub, of course. Radu, any parting thoughts? We have
no, I'm partly terrified that people actually watched through and saw me mistype commands and console log debug problems. So that was a lot of fun. I'm looking forward to.
We too like to live dangerously by doing live code. Matt says that was fun, and Fly says thanks, guys. Thanks for watching, Fly. Thanks a lot. We appreciate it. So we will see you all next week, where, like Radu said, we will build more to the same app.
I'm really looking forward to next week and having Josh tell us a little bit of behind the scenes of exactly how a random request is going from infrastructure in Fermyon Cloud to a GPU somewhere that's running sustainably and crunching data and returning the responses pretty fast. So I'm quite excited for that.
All right. Thanks for joining us again, folks, and we will see you next week at around the same time. Please hit that subscribe button as well. Till then, see you and have a good one. Bye.
Bye.